Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Neutrinos are fundamental particles that played an important role in the early phase of the universe. They are key to learn more about the fundamental laws of nature, including how particles acquire mass and why there is more matter than antimatter. Despite being among the most abundant particles in the universe, they are very difficult to detect because they pass through matter with almost no interaction. They are therefore often called ghost particles. Neutrinos have been known for several decades and were very important for establishing the standard model of particle physics. But most neutrinos studied by physicists so far have been low-energy neutrinos. Previously, no neutrino produced at a particle collider had ever been detected by an experiment. Now, an international team including researchers from the Laboratory for High Energy Physics, LHEP, of the University of Bern has succeeded in doing just that. Using the phasor particle detector at CERN in Geneva, the team was able to detect very high-energy neutrinos produced by brand a new source, CERN's Large Hadron Collider, LHC. The International Phasor Collaboration announced this result on March 19 at the Morient EW conference in La Thouille, Italy. Phasor enables investigation of high-energy neutrinos. The properties of neutrinos have been studied in numerous experiments since their discovery in 1956 by Clyde L. Cowan and Frederick Raines. One of the leading experiments to study neutrinos is the Deep Underground Neutrino Experiment, DUNE, being built in the USA. The University of Bern is a key contributor. Experiments like DUNE are general purpose and can study many properties of neutrinos from a variety of sources. One aspect that is not covered is very high-energy neutrinos. The highest energy accelerator available is the LHC at CERN, where new particles are produced by two beams of protons smashing together at extremely high energy. However, neutrinos have never been detected at any collider because they escape the existing detectors at the LHC. The phasor experiment was proposed to fill this gap. In this experiment we measure very high-energy neutrinos produced by the LHC collider at CERN. The goal is to study how these neutrinos are produced, what their properties are and to look for signals of new particles, says Akitaka Ariga, leader of the phasor group at University of Bern's Laboratory for High Energy Physics, LHEP. The LHEP is part of the Physics Institute and of the Albert Einstein Center for Fundamental Physics, AEC. The phasor experiment is a unique idea at the interface between the highest energy colliders and neutrino physics. Often new discoveries are made when taking such new approaches, says Michelle Weber, director of the LHEP of the University of Bern. Hidden physics in neutrinos? For the current observation of neutrinos, the experiment took data at the LHC in 2022. The team detected 153 events that are neutrino interactions with extremely high certainty. The neutrinos detected by phasor are of the highest energy ever produced in a lab and are similar to the neutrinos coming from deep space that trigger dramatic particle showers in our atmosphere or the Earth. They are therefore also an important tool to researchers for better understanding observations in particle astrophysics. This achievement is a historical milestone for obtaining a new neutrino source with unexplored features, says Akitaka Ariga. The presented result is just the very beginning of a series of explorations. The experiment will continue to take data till the end of 2025. There might be hidden physics in neutrinos at high energy scale, says Akitaka Ariga. This project has received funding from the European Research Council, ERC, under the European Union's Horizon 2020 Research and Innovation Programme, Grant Agreement No. Thanks for watching. Please subscribe my channel for more videos.